value will be higher than this threshold. Let's assume that this threshold tends to infinity, to plus infinity. In this case, for all objects, this value will be less than this threshold. And so by tuning this threshold, we can take into account the imbalance of the class imbalance and tune the proportion of false positive and false negative errors. Because the more this threshold, for example, in this case, the closer this threshold to +1, the more sure we are in the prediction that the object belongs to the positive class, but at the same time, our predictions for objects that they belong to the negative class, these predictions are less sure. And it's obvious that in this case, the proportion of errors will be higher and vice versa. So by tuning W0, we can balance different types of errors. Let's denote by lambda a penalty when object from a class Y is misclassified. And so, in order to introduce this weight into the loss function, we just take this indicator. So, in this indicator, the condition is that the prediction of the classifier doesn't coincide with the label. And this is just the weight, the cost of this error. And so by tuning these weights, we can increase attention of the classifier either to errors of the one type or to the errors of another type. Now let's denote one of the main metrics used to assess classification accuracy, so-called ROM curve, receiver operator characteristic curve. So the idea of this curve is quite simple. First of all,